have seen the growth in the connectivity aspects. You must have seen the mobility, right? The applications requiring mobility support. So we have multiple dimensions in terms of emerging applications. And cloud has been like one those key technologies supporting, many aspects of businesses. Now we are looking at some other pillars of the technologies which can contribute to the growth of 5G. So SDN, now if you see here, why SDN is such a big deal? Because it makes the IP routing quite flexible. Decoupling the control plane in the data plane offers this flexibility, right? And then in terms of having distributed kind of architecture of the traditional network, that distributed architectures of the control plane, you have a centralized controller, and this centralized controller can then offer the global view. So you have uh, a global or the central view of these resources. Overall, you make the network programmable, and it adds agility to the to the requirement, to the business requirements. Now let's have another look in terms of the complete SDN architecture, where you can see on the top you have various network applications, right? For example, you have a customized routing logic, right? You may have another application maybe related to uh, the firewall policies, right? So you can run each of these applications. You may have NAT as another application. So multiple such applications running on the application layer, communicating with the SDN controller, which is shown here as network operating system. So same as like your traditional operating system, uh, offers an intermediate layer between the applications and the hardware devices like your CPU, your RAM, right? So similarly here, in case of the SDN architecture, you have the SDN controller uh, supporting, that job of an operating system. So you have system connecting various applications with the devices, uh, handling the data traffic. And these devices are called as forwarding devices or the flow devices. Now, these devices are very light compared to the switches we have seen in the traditional network. Okay, so this shows your APIs or the application programmable interfaces, right? So one can have multiple options. RESTful API, that is a very standard one. You can use, in fact, much better options. These days, you have got open standard, uh, available on uh, the application interface where applications can communicate with the SDN controller. So you have gRPC. So either you can use REST architecture to connect the application with the SDN controller, or you may have another architecture that is based on remote procedural calls. So I'm not going into the details, but Google has adopted advances in the remote procedural calls, and one of the protocols that is also quite widely used is gRPC. Okay, then you have RESTconf, NetConf as another choices on the upper side as an API, whereas on the southbound side, southbound, why? Because it is on the down or the towards the south of the SDN controller. So you have options as OpenFlow, right? That is one of the very standard ones which was introduced. Now we have much better options than OpenFlow, okay? Because of the scalability issues with the OpenFlow. Now, overview of an SDN controller. So essentially speaking, in the SDN architecture, you have an SDN controller as one of those important or key elements. And the second one, you have those forwarding devices or the flow devices. Okay. Now, when you look at the SDN controller, and when I'm saying that the SDN controller is responsible for providing a global view of all the forwarding devices underneath it or just below it. Below means like all the devices under the control of that SDN controller. So you can have an SDN controller representing a region. For example, you have a SDN controller for region 1, another SDN controller for region 2, something like that. And this way, you can have a much wider view of these devices which you can manage. So I think this is a much better way of managing the network uh, as compared to what we have been doing with the traditional networking, using the traditional network management software tools where the operator is responsible for making certain changes or for making certain changes in terms of applying some security policy, for example, right? So any change in terms of change in the network topology or change in terms of the policy based on the requirement from the business side, all these changes can be done quite fast, right? So when I say that you have like a SDN controller providing a global view, essentially speaking, this is going to minimize your uh, time to make changes in policy or in configuration on all these devices at once. So I remember previously when we had our network operator, when we used to give him certain requirement, he used to take several hours, sometimes days, to even fulfill a very simple requirement, right? So you can imagine that this SDN network offers not only just the flexibility, but you can see that time to make those changes on each of these devices has shortened to like few minutes rather than hours and days. Okay, so this gives you an overview of software-defined networking. Now, another important technology which is actually growing and supporting the growth of 5G. I have taken 5G as an example to understand these two pillars of technology so that it becomes quite easy for you to see the services being offered by 5G network, right? So when we are talking about how networking has progressed or how networking has evolved in last few years, it is very important to have a bigger picture in terms of how 5G is providing different services and how SDN and NFV can support such services being offered by 5G or to understand the capability aspects of 5G. Now, network function virtualization, before we talk about NFV or when we talk about NFV formally, it's important to understand the impact of virtualization. Virtualization has been existing for quite some time, right? So if you go and read about virtualization, or many of you must be knowing about virtualization because you must be using or having virtual machines on your laptop or in the lab, right, to do certain tasks, right? So we all know that the virtualization was first used by IBM and has actually seen, so that was like 60 years ago, more than 60 years ago. And the commercial or the large scale use of virtualization became uh, more evident in late 90s, right? So after the VMware introduced, the virtualization technology to the world, it became much more popular. So we have been using virtualization for more than 20 years at a commercial scale. And what we have seen is we can virtualize almost every aspect of the hardware we use, right? So since we have seen that we can virtualize servers, we can virtualize the desktop environment, right? So on the same line, we are looking at how we can virtualize the network hardware, right? So the traditional network, as we know, consists of routers, switches, firewalls, links, right? So the question arises, can I create a virtual network on my PC? So the answer is yes, right? So essentially speaking, you can create a virtual environment of the network on your PC. So there is a tool called Mininet. So some of you must be knowing. Okay. So you can create a virtual environment where you have routers, switches, firewall links, and then you can accomplish certain task. Something like doing some routing task, right? Doing some changes in the configuration, right? Changing the security policies, right? So this is another dimension of the virtualization, alongside how we have seen the virtualization for uh, the other different types of computing hardwares or OS or applications or servers. Yeah. Now, when we are talking about virtualization, so I'm not going into the details because this itself is like a very vast topic. But what I'm trying to explain here is those essential elements which you need to understand uh, when you try to learn more about network function virtualization, right? So here you have got some softwares like you have hypervisor here, something like Oracle VirtualBox. So when I give you some task that do some lab task on Mininet. So first of all, you have to install the Mininet, right? And to install Mininet virtual machine, right? So you can see here, you require a software. So I have one virtual machine here corresponding to an application, another virtual machine for another application, right? So you can host several such virtual machines corresponding to each of these applications. And these virtual machines can run on the top of a software which is called as hypervisor, right? So here I have shown some of these hypervisors one can use. So when you are doing a very small scale task, I can use uh, a virtual box, right? Oracle VirtualBox, or you can use. So there are two types of hypervisors one can use, right? So depending on your need. So if you are working on an enterprise network, you can use a hypervisor to meet the requirement of enterprise network. So you can see here some of these hypervisors I have shown here, and the purpose is to host these virtual machines. Okay. So virtual machines, we all know, actually is used to create a simulated environment, right? And each virtual machine can then share your like memory. So how I can divide or how I can share compute or the storage resources. So I don't need to then worry about migrating from one operating system to another operating system. So all I can do is I can run several virtual machines to create this simulated environment. For example, here I'm talking about software defined networking. So here I can uh, ask you to install Mininet virtual machine on the top of Oracle VirtualBox, which is working as an hypervisor, right? Similarly, I can ask you to understand network function virtualization and can ask you to download another virtual machine corresponding to open source NFV architecture, right? So there is a tool called Mano, right? So OSM. So that open source NFV architecture can also be downloaded on the same Oracle VirtualBox as long as you have sufficient RAM, because each of these virtual machine will require some RAM. For example, Mininet would require 2 GB. Similarly, the open source NFV will also require another 4 GB RAM. So you have to have at least 8 GB RAM to support these two virtual machines. Now, contrary to the traditional uh, virtual machines or the other tools, hypervisors, there's a growing trend these days in terms of using Dockers and containers, right? Now, this growing trend is based on the the microservice architecture, right? So we have to have a support from the virtualization where you can't manage, I mean, you can't afford to have a very large footprint. When you look at the virtual machine still is quite heavy when I'm talking about supporting a very fine scale, the requirement, something which is needed for the microservices. So we need a lighter footprint from the virtualization technology point of view, and container actually fills very well. And there are many example container software, something like Dockers, Kubernetes, right? Amazon ECS. So if you are specifically interested to learn more about containers and work on some project, uh, I'm sure some of you must be working on some project which is making use of Kubernetes, right? Now, the best part of containers is like it boot quite fast. They are very lightweight, right? So compared to virtual machine, containers are lightweight, very fast. And the overall goal of using container is to support microservice architecture. And then the third important reason, or the compelling reason why we use container, is this portability aspect, right? They can run from anywhere. Same as SDN, NFV is also seeing a very, you can say, consistent growth. Now, if you look at this similar kind of market research data, the global NFV market has grown threefold in the period from 2019 to 2024, from $12.9 billion to $36.3 billion, quite similar to the figures we have seen for SDN, registering a cumulative annual growth rate of 22.9. So it's slightly more than what I was discussing for SDN in different regions. So the wider adoption has been registered here when you look at all of these market research data or market research statistics, mainly in North America. So you must be wondering about what is the major motivation for the network function virtualization, right? When we have specific hardware that can manage a specific networking function. For example, you have a device as router, which is supporting a routing function. You have a load balancer supporting load balancing as a networking function, right? You have a firewall, which is supporting policies. Similarly, you have a DNS device performing, uh, the domain name services, or you have VPN. So all these devices are actually supporting some kind of network function uh, on a vendor specific hardware, right? Now, these are like a specific proprietary hardware. And as I mentioned before, that when we talk about the innovation, when we talk about introducing new features, uh, specifically managing the interoperability aspects. So even if you can manage interoperability, I mean, if you can support interoperability, managing interoperability is quite challenging, right? So instead of those challenges, I mean, these challenges can be addressed very well if you have a virtual router, virtual firewall, virtual switch, virtual DNS, all these functions running as software rather than, so I can run these functions as a software on a server, right? So you can see that NFV, or the network function virtualization, is a transition from decoupling these network functions, which are otherwise running on a proprietary hardware, and running them on a server as a software network function. Okay, so network function virtualization decouples these network functions. SDN is decoupling the control plane from the data plane. What NFV is doing is decoupling the network functions from a specific network hardware and running it as a software function on a server, right? So that you can easily manage the life cycle of these functions using NFV architecture. Yeah, so this gives you even a better view of how this monolithic architecture where you have these devices running these network functions on these proprietary hardware to on the right hand side, it shows how you can run these functions as software, something like encryption as a function, DNS as a function, all of these running on server as virtual CPE. So how does NFV help in digital innovation now when we are looking at the growth of applications or the growth of data, growth of emerging applications, right? You have got a growth in the IoT applications. Uh, you have seen or you have witnessed like a tremendous growth in data, right? Many big data applications coming from various industry verticals, right? So we had to improve our legacy or the traditional networking. And as I mentioned in my previous topic as SDN, how SDN had evolved from the traditional networking, and now we are seeing that how NFV is complementing to the advances in networking through virtualization or through, I should say, network functions, right? Through softwareization. So where SDN is offering or supporting programmability aspect for managing the data traffic, for managing these devices running at the infrastructure layer, right? So it offers programmability, right? So you have seen those APIs you have, and through those application programmable interfaces, one can easily manage these the data, and one can easily have a complete view of the devices which are participating in managing the data traffic. NFV, on the other hand, is managing those functions which you can run as software on the server, right? Now, this is particularly important in terms of saving on your capital expenditure. So instead of buying any specific or proprietary hardware, if I run a software, I mean, if I run that network function as a virtual router or as a virtual firewall, as a virtual DNS, virtual NAT. So definitely it saves my capital expenditure. And another important aspect is when I run it as a software function on the server, I can actually quickly meet on-demand services, right? So I can in fact manage real-time service requirements, right? And definitely, when I'm not dependent on vendor specific hardware, this opens like a door for innovation. And now when you have the services being met like quite quickly, this increases the customer satisfaction as well. So there are reasons why we migrate to NFE because it not only just reduces the capital expenditure, it improves the customer satisfaction by providing services in almost real time. Okay, uh, enabling innovation. So the last part of my today's talk is mainly based on how now stitching it together. So I discussed about SDN and NFV separately. Now let's have a look and see a bigger picture of both technologies together. Of course, one can make use of SDN independent of NFV. Both technologies can be used independent of each other. But if we can have SDN with NFV, they can definitely complement each other. Something which we can see for the success of 5G rollout, right? So this shows that 5G adoption rates have seen phenomenal growth, and this is quite evident from various areas where we have seen how 5G can support uh, based on the 5G capability of connecting more devices, right? So 5G can support up to 1 million devices in 1 square kilometer. So that is the connectivity capability. Can offer much more bandwidth, right? Much higher data rate compared to its uh, predecessor 4G. So there are many applications requiring very high data rate, right? Like autonomous vehicles or could be AR, VR applications. When we talk about IoT, these IoT application may require 5G capability in terms of connecting these devices, right? So you may have many IoT devices, maybe like 1 million devices in 1 square kilometer. So there we can make use of the 5G capability of connecting millions of devices in 1 square kilometer, right? So there are many industry verticals where we can actually, so there is another capability of 5G, the third one, where you have ultra low latency and the reliability requirements from certain applications, including autonomous vehicles, right? Some mission critical applications. Okay. So where you have a very low, ultra low latency requirements ranging from 1 to 10 milliseconds, right? So there we can make use of 5G as well. So for the 5G market is also expected to grow from US 12.3. So this is like a tremendous growth compared to the other two technologies. So that's why you can see the pillars supporting the success of 5G. You can see there's the huge scope. Similarly, I mean, there's a huge scope for the 5G adoption. And of course, by 2035, we may see 6G existing by then, right? So since you have a tremendous potential for the 5G and beyond, so we need to understand what are the technology pillars supporting the success of this 5G, right? So SDN, NFV, these are the two technology pillars. I'm not going to cover the other pillars. Uh, this is multi-access edge computing. Okay, I can touch upon when I present one specific use case of SD and NFV contributing to the success of 5G. Cloud, we all know, is technology supporting the resource provisioning, right? IoT supporting how we can collect data, right? Using low-cost sensors. So altogether, if you look at this diagram can give you a very high-level view of how NFV, cloud, SDN. So in fact, with this diagram, you can clearly see that there is no boundary now between the cloud and the network, right? So that boundary has diminished. Okay, so this Venn diagram is showing you that if you want to support the automation, so it's between NFV and the cloud, where cloud supports the resource virtualization, NFV supports the function programming. So as I mentioned before, I decouple those network functions uh, from the proprietary hardware, vendor specific hardware, and I can run them in software, right? So that's why if you see here that NFV and SDN, if they work together, they they both support the softwareization. And if you look at all three of them, they support network orchestration. Okay. Now, network orchestration is very network service orchestration is very important because you can decompose any network service into a series of network virtual functions. So this is something that your NFV architecture can support, that how any specific network service, maybe like the service can be defined here as a deep packet inspection, right? Or you can have intrusion detection system, right? So if you are doing this deep packet inspection, end-to-end deep packet inspection, now this service can be decomposed into several virtual network functions, and therefore it is very important to have real-time monitoring, end-to-end real-time monitoring of these network functions. Okay, so you have to have a service, you have to have a framework which can allow you to have real-time monitoring of these network functions. Okay, so end-to-end monitoring of these network functions in real time is an open research problem which some of you can explore. Okay, so this inner intersection which you can see here is corresponding to the intersection of these three technologies. I think this can give you a better connect in terms of how this orchestration layer can support, in the 5G ecosystem, right? So impact of orchestration in the 5G ecosystem can be seen here when you have an orchestration layer uh, sitting between the 5G core network, and you have many edge servers, right? So what you do here in the 5G ecosystem is you disaggregate, the uh, centralized network function, and you disaggregate into various uh, multi-access edge computing servers, right? So each of this box is supporting these servers running those virtual network functions. Okay, so this is like a disaggregated radio access network. So what I have done in the 5G to virtualize the radio access network hardware, and so that's why you don't see much of hardware these days. You see why? Because you don't see it because you have the virtualized radio access network, and that runs on the edge servers. So you have multiple such edge servers running those radio access networks. Okay, so here the virtualization which I was talking previously, in terms of basics of virtualization for 5G, you can see that the virtualization technology will virtualize the radio access network hardware that we run on these edge servers. Okay, so here you can see how it supports when you look at the bottom, any specific service continuity when you expect between uh, supporting actually the mobility, right? So this is a specific use case of mobility, um, uh, for a vehicle or for an autonomous vehicle maybe, where a vehicle is passing from one base station to another base station. So how between these two base stations, definitely we understand it as a handover, right? So how we can have zero downtime between the services being offered by two edge servers, right? So this edge server is connected to this base station, whereas you have the other edge, sorry, other edge server connected to this base station, right? So when this vehicle is passing from one base station to another base station, how you can have service continuity that is based on supporting uh, what you call the real time migration of the service, right? So how the real time migration happens or is being supported, this is the responsibility of this orchestration layer. So definitely you have a global orchestrator which is coordinating with the local orchestrators to support this service continuity for this particular use case. Okay, so this is a mobility use case where we can exactly see how SDN NFV can support by introducing an orchestration layer to support migration of a network service, which is decomposed, of course, as virtual network functions. Now, each of these virtual network functions are supported by these servers. Okay, so this is going to be my last slide in terms of how SDN NFV can support the success of 5G, you can see that one of the key concepts in 5G is the network slicing. Now, this network slicing, when we talk about network slicing, it is more about slicing or having a slice of a network depending on the, the service requirement of a specific application. So let's consider here uh, a smart factory or the factory of the future application where you have got various robotic arms, or it could be like an industrial automation facility, something like a BMW car manufacturing facility, right? So you have various such objects communicating with each other to accomplish certain task in a smart factory. So they have a specific requirement from the 5G capability, where the 5G capability is supporting, the high data rate requirements, much more connectivity kind of capability, or ultra low latency and the reliability type of capability. So depending on the capability of the 5G, there are three major uh, capability aspects of 5G, right? Related to the data rate, connectivity, and latency, ultra low latency. Or it could be a slice which is specifically needed to support autonomous vehicles, could be another network slice supporting IoT type of traffic. IoT type of traffic is not having very high data rate requirement, right? So IoT devices are mainly responsible for collecting data, which can be communicated at a lower data rate. Yeah. So depending on the service requirement, you can have a specific slice of, so slice means slice of the resources that 5G network can support. And these resources are definitely end-to-end resources when you talk about supporting, a specific service from one point to another point. Okay. So as I mentioned in my previous slide, this gives you uh, a sufficient idea of how SD and NFV together can contribute in terms of supporting network service orchestration. Um, I mean, if you want to learn more about 5G, I led a team of some academics here at Curtin University in past 2 years, right? So during COVID-19 period, I was very busy in developing some online courses. In fact, like 2 certificate programs I developed in last 2 years. So one on software-defined networking, another one on 5G networking, right? So you can see here there is a professional certificate program on 5G, and if you want to learn more about this, I would request you guys to go through this and see if this is useful, because this course is specifically based on developing, some industry relevant skills and knowledge. So this certificate program has got 2 courses. One that covers the fundamentals of 5G, right? Talking about uh, the the 5G capability aspects and various use cases. Whereas the second course is more about the 5G deployment aspects, right? You can learn more about network orchestration, network service orchestration, network slicing, right? And the radio access network, how the virtualization happens in the radio access network, and how multi-access edge computing can support 5G. Right, so all these important elements of technology, similarly how SD and NFV can help 5G as well. So this is one course, and this is one certificate program. And the other certificate program is based on software-defined networking. Right, so this has got 3 courses. One that is Introduction to Software-Defined Networking. The second course on Software-Defined Networking Access Security. And this course also has got some specific focus on cybersecurity challenges. And I guess this session is being organized by your cybersecurity cell. So there might be some interest from your group who can then do this. And the third one is based on software defined networking deployment. Now that actually uh, uh, allow you to deep dive and then learn more about the deployment side of software defined networking. So these are the two important certificate programs that I developed with the help of my team. And I would now request Maya to run this short video, okay? And then the session will be open for questions, okay? Would you like me to stop sharing this? Hello? Hello? Can you hear me?
Yes, yes, sir.
Okay,
I
so
will run video shortly.
yeah.
Sir, just 2 minutes. We are trying to open it.
Okay. Is it difficult?
Sorry, sir.
Is it difficult to play the video?
No, sir. Now we are opening Gmail, so it is taking some time because of
Oh,
internet connectivity issue.
okay.
Just 2 minutes, sir.
Okay. In the meanwhile, if somebody has any question, can post it in the chat.
Yes, yes, sir.
Yeah.
Sir, now video is played.
Okay. How many
So,
how many students are
sir,
attending this?
there are 130 students,
Okay. Okay. Good.
but we have started it in Central Seminar Hall. So there are
Uh-huh.
only few links from our side.
Ah. Okay.
Sir, after this video, students will ask you questions.
Sure.
Yes. Hello, sir.
Yes. Hello. Yeah, I can hear you.
Sir, video is done.
Yep.
I think there are two questions in chat box. Can you please answer
Sure.
this?
Okay. So the first question was about the duration of the course, right?
Yes,
Uh,
sir.
so to answer this question, I would say that we have in each certificate program, uh, like one for software-defined networking that has 3 courses. Each of these courses can be done in the self-paced manner, which means that you can do it as per your convenience by sparing 2 to 4 hours every weekend or during the week, whichever is convenient to you. And you have like several interactive activities, you have several videos, a text for reading, then various labs, practical activities, right? So everything you can do by spending 3 to 4 hours for each module. So for instance, first one has got first course has 6 modules. That means by spending around 20 to 24 hours, you can finish that course. Similarly, the second course, you can spend another 20 hours. So altogether, you can spend around 50 to 60 hours to complete the entire certificate on software defined networking. For the 5G, you can spend around 20 to 25 hours for each. That means in around 40 to 50 hours, you can finish 5G certificate program as well. Yeah. The other question is, what are some security technology used in software-defined networking? That's a good question. So now when we are talking about having a holistic view because of the threat vector, right? So now when you have the workforce which is working from home, right? You have so you have like a complete change in the workforce also. Uh, Previously, we used to have the workforce working from home only during in the IT sector. Now you must have seen during COVID-19 a big change in terms of people working from home. So this is one big change in terms of people working from home, and you know you have to have a complete support from the security aspect as well. So this is another threat vector when we talk about the cyber security challenges. So this question actually refers to how we can use software-defined networking, to support this growing vector of threats, right, leading to cybersecurity challenges. So we have several, technologies. So we all know about the segmentation, network segmentation. We all know about several products we have used to secure an endpoint. For example, firewall. You have used DMZ, right, to protect these servers, public facing servers, something like web servers, email servers in any organization. You can create a DMZ to protect these servers. So essentially speaking, in last 30 to 40 years, we have used several security solutions, starting from firewall, dematerialized zone by placing two firewalls to create a zone, security zone for public facing servers like web server or email server. You have intrusion detection systems, intrusion detection and prevention systems. Then you have honeypots, right? So all these technologies we are already aware of. Now we talk about next generation firewall. We talk about real-time threat intelligence, right? So we extend our prior, understanding from network segmentation to micro segmentation. And if you are keen to learn more about this, I have introduced this in my second course, software-defined networking security, and covered more about zero trust, right? So the new developments can be seen in terms of zero trust network architecture, okay? And that is explained in detail in my second course of this certificate program in software defined networking, okay? Which that means we we work on not trusting any device, any application, any data, or any user, okay? So in any network, now you have users, you have application, you have data, uh, and you have devices, right? So we can't trust anything. We can't trust anybody. We can't trust any application. We can't trust data either, because you have some, the maintenance team people coming from outside using your network as long as they are in your campus. So this is again like posing to those security challenges. Similarly, you have the data being collected by IoT sensors, challenges related to the data part. Applications, another challenge. Yep. So you have to have a holistic view of threats coming from each part: data, device, application, users, right? So there is what you call a journey from the network segmentation to micro segmentation, and which is now available as zero trust network architecture. Does it answer?
Yes, sir.
Okay.
So
So
there is
what
one
are
more.
there is one more question. So what are some standard practices used while developing SD, and also some tools we can use to play with? Well, I think what we have done here is we still allowed the learners to make use of Mininet. So one of the standard tools is Mininet, which can essentially allow you to create a virtual network on your laptop or on your PC, and then you can accomplish uh, tasks related to networking, right? For example, load balancing or um, assigning policies for firewall, right? So all those traditional network functions which you can do on any traditional network, you can do it by using certain tools like Mininet. So Mininet has got a very good plugin with various open source tools, right? So you have the controller, SDN controller, which is also having either Java based controller or you can have Python based. So if you are quite comfortable in Python, you can use some controllers like Ryu controller, Ryu SDN controller, and can then write a Python script to accomplish these networking tasks. Yeah. So another tool for NFV, as I said, is open source OSM. So if you want to play with OSM, I mean, if you want to learn more about NFV, so this is again covered in one of my first course that is network SDN introduction to SDN. Okay, so all these courses in the certificate program, they have got interesting stuff to read, interesting videos to play, and interactive activities which you can do, and some practical lab activities which you can do to connect very well with what you have learned while you read or play some video. So overall, I think it can be a very rich experience and good to put it on your resume when you go for an interview, for internship, or for a job. So I think it's good when you acquire some industry specific or industry relevant skills. Yeah. Any other question?
Sir, I think no.
Just three questions from many students. Anyway, thank you so much. I think uh, I hope I delivered what was expected from me.
Yes, sir.
Okay.
So, in fact, we are very fortunate to have you as our expert. As you
No,
know, this
I
was
mean,
the most awaited session.
I'm sorry that we tried and it never happened before.
Sir, it was very good session. Sir, I would like to request Sammy. He is member of Cyber Bot Club. He is official member to give vote
Okay.
of thanks.
Okay.
On behalf of IT department, I would like to express vote of thanks towards you for delivering expert session on software-defined network and network function virtualization for 5G. Sir has given a detailed idea on SDN controller, mininet tool, use of containers, and Sir also discussed key enablers for SDN and NFV for 5G, and explained in detail about the role of NFV in digital innovation market of NFV growth by 2035. And hope students will also be keen in, will have an interest in your courses available and will help them for the future. Thank you, sir.
Thank you so much. Okay. If there is no other question, then in that case, should I close from my side?
Sir, once again, thank you so much. We would like
Oh,
to listen to you in future,
okay.
future as well.
Sure. As long as I have capacity to spare time like this, I'll certainly, I don't promise now when I'm going to do it next, but certainly I would love to do this because this is one part where we enjoy engaging with wider community.
Yes, yes. Thank you, sir.
Okay. Thank you, Maya.
Yeah.
Okay. Bye.
Bye, bye, sir.